Okay, so in class today we're talking about the product and quotient rule. I kind of want to just finish up that. I know some people are at every class we're in a different spot. So kind of fast forward if we've already covered it, continue on if we haven't. So going back to this one, this was the first example under the quotient rule. We really want to look at denominator versus numerator. And the quotient rule said if we take the derivative, sorry, let me get a pen first and foremost, always like in class. If we take the derivative of this, the quotient rule says the first thing we're going to do is take the derivative of the numerator, derivative of the top, times the bottom, our denominator as is, minus derivative of the denominator, which in this case happens to be 1, times the numerator, the top. And then all of this is going to be over the bottom squared. Okay. After this is just simplification. We're just going to distribute and combine like terms. Biggest thing you want to make sure that you do is when you distribute out that negative with that value, so that negative 1. So that's going to become a negative 2x, and that's going to become a positive 1. And don't forget the fact that you do have a denominator. Always follow that along. You don't need to expand that. Go ahead and leave that in factored form. Combining like terms, our 2x's will cancel out, and we'll have 7 over x plus 3 squared, and that is our derivative. Okay, next one, our tangent. We have a derivative for sine, we have a derivative cosine, but we don't have a derivative tangent. But sine and cosine are the most important ones because every other function can be written in terms of sine and cosine. Tangent is sine of x over cosine of x. That means it's a quotient, and because it's a quotient and I know the derivative of sine, I know the derivative of cosine, I can take the derivative of this using my quotient rule. Okay. Quotient rule says the derivative of the top as a positive cosine times the bottom, which is cosine, minus the derivative of the denominator, that's negative sine, times sine. Then all of that over the bottom, or our denominator, squared. Simplifying that out, we get cosine squared of x. That negative and that negative are going to become a positive, and then sine squared x over cosine. Okay, and I could have rewritten that. Okay, so if we look at the top, cosine squared plus sine squared, that's our trig identity. That's actually equal to 1. So in reality, I have 1 over cosine squared. Okay. Well, 1 over cosine is secant, so I can rewrite this as secant squared of x. That means the derivative with respect to x of tangent of x gives us secant squared of x. Now you have two options here. You can either know the derivative of tangent, like we know the derivative of sine and the derivative of cosine, or you should be able to find it using this process. So I'm going to highlight this. Okay. Going on to the next one. We have f of x equal to, and then we have a quotient. So we can use the quotient rule. So f prime of x, derivative of our numerator, so 3x squared plus 4, times our denominator, times the bottom, minus derivative of the bottom, our denominator, which is 1, times the top, which is our numerator. And then, of course, all of that over x minus 2 squared. So let's kind of simplify this. We're going to distribute on that first set. So we're going to get 3x cubed minus 6x squared plus 4x minus 8. Distribution of that negative 1. X cubed minus 4x minus 2. Again, don't expand out the bottom unless you need to. We want it in this form because factored form is the best form for simplification. Okay. Now combining my like terms, I'll see that I get 2x cubed. That and that are going to combine. I have a minus 6x squared taking care of that. That positive 4x and that negative 4x will combine to give us 0, so we don't even need it. And that negative 8 and that negative 2 will give us negative 10 over x minus 2 squared. And that's all we can do, so we're going to leave that as the derivative. Cotangent is the reciprocal of tangent. Since tangent was sine over cosine, this is going to be cosine of x over sine of x. Again, a quotient, so we can use our quotient rule. Put a little line right in the middle there. So my f of x, or my f prime of x, derivative of the top times the bottom, minus, and I'm going to run out of room, so go ahead and make sure you have that on the side because I'm going to erase it and kind of move it. Okay, so we're going to erase all of that really quickly. And then what I'm going to do is just move that. Let's see if I can move it. There we go. Give me a little bit more room. Okay, so minus derivative of the bottom, which is cosine, times the top, cosine, and then all of that over sine squared of x. So I'm just going to go ahead and write it like that. Let's combine some things. So we have negative sine squared of x minus cosine squared of x over sine squared of x. Now if we look at the top, it looks very similar to the Pythagorean identity, except for the fact that both of them are negative. However, I can factor out a negative 1 and get positive sine squared x plus cosine squared x all over sine squared x. And now that we have that identity, both are positive, that's equal to 1, so we really have negative 1 over sine squared of x. And if we think about that, that's negative cosecant squared of x. That means the derivative with respect to x of our cotangent function is equal to negative cosecant squared x. Again, I'm going to highlight this one. That's again another one you need to know, or you need to be able to find, either one. So now let's look at some different type of problems. Still quotient rule, still product rule, but a little bit different. So what we're going to do is we're going to look at some graphs. So we have the graph of f right there. Sorry, we have the graph of f, g, f prime, and g prime. So the graph of g and g prime right on top of each other, the derivative, and f prime. So it says suppose h of x is equal to f of x times g of x. Find h prime of 2. So the first thing we want to do, in order to find h prime of 2, the first thing we need is h prime of x. But because this is a product, all I'm going to use is my product rule. Same way. So f prime, derivative of the first, times the second, plus derivative of the second times the first. Okay. Remember, we're in calculus, so you want to show the calculus aspect of it. So that right there is the derivative. That is the calculus. You need to make sure you show that. Just don't go plugging in all at once, because you want to show that you know what it is you're plugging into, and that equation right there shows that. Once I have that, I can find h prime of 2. Everywhere there's an x, we're putting in a 2. All this is function notation. Okay, and this is where the graphs are going to come into play. Let's change color. Let's go with that color. Let's go a little bit thinner. Okay, so the first thing I want is f prime of 2. So I'm going to go to my f prime graph, where x is 2. My f prime is 3. So that value here is 3. G of 2, I'm going to my g graph. So where x is 2, my g is in fact 2 as well. So 2 plus g prime, we're going to our g prime graph where x is 2, g prime is 1. So this is 1. And our f graph where x is 2, my f is 2 as well. And then all we're going to do from there is calculate this. Sorry, there should be an equal sign right there. So 6 plus 2 gives us 8. So even though we don't know what h of x looks like, we can find the slope using the graphs of f and g, f prime and g prime. Same thing goes for the one below this. If I want to find the derivative, h prime of 2, the first thing I need to do first is find h prime of x. So I'm going to use, sorry, I don't need that. First thing I'm going to do is find my derivative. That's a quotient, so I'm going to use my quotient rule. The quotient rule says derivative of my numerator, derivative of the top, times the bottom, our denominator, minus derivative of our denominator, times our numerator. All of that over our denominator, our bottom squared. So now that that's the case, I'm going to put a 2 in for every x. Everywhere there's an x, I'm replacing it with a 2. Function notation. So we're going to put some values in. So f prime of 2, we kind of already got that from our graph. So f prime, so that's this graph, when x was 2, our f prime was 3. G of 2 on our g graph, that was 2, minus our g prime, which was 1, and our f of 2, which was 2. And then of course going back to our g of 2 itself, which was 2 squared. We're just going to do some calculations. We get 6 minus 2, which is 4, over 4, which is equal to 1. Okay, so remember, the big thing about these is you want to show the actual calculus piece. The points on your paper are going to come from the actual calculus, and that's those two equations. So I know it seems arbitrary to write them, but they are pretty necessary for calculus credit. Show how you're getting the value of 8 and how you're getting the value of 1. Okay, so let's look at a different type of problem. So we can do it off the graph. We can do it off of a table as well. Same thing. We have some values for f, g, f prime, and g prime. So just like the graph, we're just going to use a table. Same exact thing. It doesn't change our process. So if I want p prime of 4, the first thing I need to do is find p prime of x. So derivative of the numerator times our denominator minus derivative of the denominator times the numerator, all of that over the denominator squared. I'm specifically looking at 4, so everywhere there's an x, I'm going to plug in a 4. And this is where that table is going to come into play. So let me get a marker. Let's go a different color a little bit. Okay. So if I'm looking at g prime of 4, so when x is 4, which is right there, I'm looking to my g prime, which is right there, which means g prime of 4 is equal to -3. So I'm going to place that in. Okay. That's that piece right there. Let's use some different colors. So when x is 4, again going back to that 4, oh, that's an ugly green. I'm looking specifically at the f function. So that's right there. So that's equal to 1 minus f prime. Go with green, and we're going still on x equals 4, so we're just going to make that brown. And if we're looking specifically at f prime, which was that 2, so that's that color right there. And the last one, we'll go back to yellow. Okay. When it's 4, so again, I'm looking at that 4, and I'm looking specifically at G. Okay, so if you look at the colors, that's where I'm getting my values from. And that was 7. And then back over f of 4, if we think about it. That was that value right there. It kind of matched that one. I already know that value to be 1. And now it's just about calculation. So I get -3 minus 14 over 1, which just gives us -17. Okay. Last one. If you want to, pause the video, try it on your own. Might be a good idea. Okay. So first thing I'm going to do is get my derivative. If I want p prime of 4, I need to first find p prime of x. So I have my first right there and my second right there. So this one's a little bit different because one of our functions, we know the actual function. That doesn't change our process at all. So derivative of the first, so it gave us 2 times the second, no derivative, plus derivative of the second times the first. Okay. After that, I'm plugging in a 4. Everywhere there's an x, it doesn't matter. Everywhere there's an x is going to 4. And I say that specifically because here, 2 times 4. Okay, it's an x, plug in a 4. So going 2, if we go back to g of 4, that gave us 7. G prime of 4 was -3. And then 2 times 4 just gives us a +8. So we have 14 minus 24, which gives us -10. So it doesn't matter whether we have an equation, whether we have a table, whether we have a graph, the process is the same. It's all about getting that initial derivative and then plugging in, because remember, these equations represent the slope. So for p, even though we have no idea what p looks like here, we know that the slope at x equals 4 is -10.